Oh, Zach, we're on the air.
Hold on. This is definitely not.
You can make about a 10-minute string of me and Zach bloopers. There's something going wrong right when we get to start class.
Hold on.
I apologize. Me too.
I'm sorry.
In fact, from the top of my heart.
It's at the bottom of your heart.
Did it turn off again?
No, it's just the board. Alright, there we go.
Right?
Just don't go really far over there.
That far over there?
No.
I'll try to stay contained over here.
Alright, we've been recording for 43 seconds.
Oh my gosh, okay, alright. Alright, here we go in 5, 4, 3. And welcome to pre-calculus, kids. Alright, and today is section 10-3, and we're going to start off with the match game. Everybody's new favorite game. Like the old games, you know, like the 80s. Okay, so on match game, let's see if you can match the first one. All right. Now, y equals x cubed plus 7 would match which of the following? What do you think it is?
Number 3.
Roman numeral 3 appears to be a what?
Snake.
Snake. And the only thing the plus 7 would do is what?
Move it up.
Move it up 7. All right, so that's a snake. Got it. Okay. All right. Second one. X to the 4th minus 2x squared.
5.
Numeral 5, because x to the 4th is a what? X to the 4th by itself is a parabola. X to any even power is a parabola. But when you toss in the x squared, it's going to bend it, isn't it? So that's the one there. Yep. Did that one last time, didn't we? Okay. What about x cubed plus 7x squared?
1.
Roman numeral 1. Very good. You guys have good instincts. All right. You've got a snake, but it's a snake with a... Okay. Bend the snake. Bend the snake, right? Okay. So that's that. Let's see. Number 4. Y equals negative 3 over x to the 4th.
Yes.
You know what? I think we did that on a previous test. What was that? Test 7, I think? First test of the semester, I think it was? Yeah. If it is something over x, it's always going to be a what? Hyperbola, right? And do you remember what happens if it is x to an even power?
They're on the same side.
Okay? That is same side instead of diagonal. Very good.
Wow.
Right? Remember, if it's 1 over x, it's like this, but it's 1 over x squared, they're together. Remember that? Okay, know the difference? All right? So it's 1 over x, but wait a minute, it's x to the 4th, but why is it upside down? Negative 3 upside down, right? Okay, so just know your basic hyperbolas. All right? And then the last one is 7 over x cubed. That's going to be Roman numeral 4, because x to an odd is just your standard diagonal, isn't it? All right? Diagonal pieces here, pictures. Okay? And it's 7, so it's normal. All right, there you go. Now, which points above are considered to be relative maxima? There's a new word for us. That sounds fancy. Relative maxima. You know what the plural of maxima?
Maximum.
Do you know what word maxima is the plural of? Okay? Maximum, right. Okay? So that is the plural of maximum. All right? Now, relative maximum, what that is? You know what? Turns out that a relative maximum is, in layman's terms, a
Peak.
peak. Going to be a trick question.
Heel.
Pair. It's a deal. It's like playing charades. Start yelling out all the answers you can think of. All right? Now, it is a peak on the graph, a relative maximum, okay? A high point, basically. All right? So, let's see if there are any peaks in these pictures here. Capital A is a peak. All right? Is it the absolute highest place on that graph?
Nope.
Actually, the snake goes up forever, so it's not the highest place over. But relative to that area, okay? You know what the word relative means? Okay? Related to what's around you, basically, right? Relative to that area, A is the highest place, okay? It'd be kind of like saying, hey, if we climb up to the highest point in Tennessee, we're at a very high place, relatively speaking, in Tennessee. But then you compare that to the peaks out in California, it's not even close, right? When you go to Alaska, it's not even close to that, okay? Then you go to Mount McKinley up there. Then you go over to Mount Everest, that blows away everything, right? Okay? All right? Anyway, yeah, so relative, all right? Relative to the vicinity, okay? Or relative to North America, Mount McKinley's the king, but it's only a relative maximum. It's not the absolute maximum, which we'll talk about later. Okay, absolute is the absolute highest. Of course, Mount Everest is all fine and dandy for the Earth, relative to the Earth, but it's like 1/3 of Mount Olympus on Mars, which is like 88,000 feet tall. Okay, not even close. That's like the solar system went out right there. Okay, so it's all relative. You never know. All right, what about the other peak that you see? Okay, D would also be an answer. In that vicinity, relative to the vicinity, it's the highest place. Of course, if you look at a mountain chain, you have a lot of relative peaks, right? Okay, and you have that one highest. All right, now, which points above are considered to be relative minima? And minima is the plural of minimum, sure. All right, so I imagine that a relative minimum would be a what?
Valley.
A valley, sure, in layman's terms. And anyway, let's see if we have any values in here. B is in basketball. C is in cost effective. And E is in effective. All right. So it looks like B, C, and E are all winners for this one. Okay. All values, right? Not necessarily the lowest valley, although in that W shape, those actually are the lowest places, aren't they? Okay. All right. The absolute lowest as well. Okay, so relative just means it's a peak or it's a valley, essentially. And there is one word actually that sums up both of these together, if you want to add this, which we will do this later. Now, in a couple of lessons from now, let's see, this is that day, okay? I'm going to date this video. But it's that day, and so we'll do the other lesson on next week. Okay?
I'm
Follow me somewhere?
What if this video falls on a Monday?
Well, that's true. See, that's what could happen. That's what I'm going to date this. Anyway, in 2 lessons, which is going to be on you know what, all right? In 2 lessons, we're going to do a whole vocabulary lesson as to what vocabulary words you have to look for in all these first derivative tests. And one of them will be relative extrema. Extrema sums up maxima and minima. In other words, what are the extremes? That makes sense, right? What are all the extremes? Okay? So basically that would be all the peaks and all the valleys all combined, right? Other people in the courtyard. Okay. Now, which graph is monotonic? What do you think about monotonic?
1.
Okay? Mono is definitely one. It's one direction. So if something is one direction, unidirectional, that means that there are no direction changes. Okay? No direction changes. It's just one consistent direction. Just waving at me in the courtyard out here. We're on the air for crying out loud. Okay. So, no direction changes, all right? And the only one of these that has no direction change would be which one? Number 3, notice what's happening here. It's always what? Increasing, because the slope is always what? Positive. Now there is this one little point of contention here. You remember what that point is called? What is it called? Okay. Where the concavity changes.
Neutral.
Concave down, concave up. That point is known as an
Inferior.
inferior point. Yeah, you just guessed it.
Inflation.
Okay.
Inflection.
Okay. Inflection point. Yes. A little rusty on this one. Okay. Inflatables. Inflation. All right. Sounds like. Okay. So. All right. Inflection point. Okay. That's what we're looking for there. It's been a long time since we talked about that. So anyway, here is that odd place. Now, okay, here's the story. The slope of the tangent line is positive, 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 there's actually one point where the tangent line goes level and then comes back up again. Okay? So it's kind of like something that has a positive velocity. Let's say a rocket's going up, and all of a sudden the rocket stalls and it hits a 0, then it reboosts itself and keeps going. So for that one moment in time, the velocity actually was 0. It actually slowed down again. Okay? However, so if you look at one of those places, don't be fooled. We're going to do this problem again in calculus on a higher level next year. Okay? But don't be fooled. Even though it is kind of a place that it stalls, here's the strict definition of increasing in calculus. Okay? Is each successive point higher than the last one?
Yes.
All the way even through there, right? And of course, aren't there infinite points? But each successive point is higher, so this is definitely increasing. Okay? Even though it stalls out, it's still increasing. Okay? So this is always increasing. That is most definitely monotonic, and that is going to be number 3. Okay? Now, there's one that almost made it, though. Does anybody see the hyperbola right next to it? Okay? What is it doing right here? Decreasing because all the slopes are negative. Okay? What about up here? Decreasing, all the slopes are negative. You might look at that and think, wouldn't that be monotonic? Because it is always decreasing, except. Okay? Again, this goes back to one of our themes of the day. It does not exist. See this right here? If the function doesn't exist, how can you describe the slope? The slope doesn't exist either, does it? The derivative doesn't exist. Okay? So it is always decreasing except at the asymptote. It's not decreasing there because it doesn't exist. Okay? So that's almost monotonic, but that one place messed it up, the vertical asymptote. Okay? So just to be all right? Okay, now, which graph has an increase followed by a decrease? 2 of these graphs have it. Let's see. Definitely 1 and definitely 5. Do you see that f prime is positive here for all the tangent lines? And then over here is an f prime negative? That's an up-down. And when you have an increase-decrease, do you know what you have in between? You have
0.
A is a 0 slope, but more importantly, we just learned today. Right about over here.
Minimum.
A relative maximum, yes. A relative maximum is where the slope was going up, levels, and then the slope's going down. That's like the peak of the roller coaster, right? That's what a relative maximum is. A plus followed by a minus on your derivative test, okay? So that's that one. And then what did we say the other one was? 5, all right? So number 5 is the W shape. And guess what? If you have the slope positive, be neutral for 1 second and then go to slope negative, that again verifies a what? Relative maximum. The only time you can have a relative maximum is when you have an increase going to a decrease. Just like that. Okay? So both of those are valid. All right? So kind of watch out for that in the future, next or a couple of days from now. Okay? Watch out for the plus minus.